So the general formula for all thermometers. But before we go there, as I said earlier, tutakuja kuona mbele the fixed points. So for this case tutaelezea maana ya upper and lower fixed point. For any thermometers, kama unakumbuka tulisema lazima iwe na fixed points. Fixed points kwamba lazima kuwe na upper limit ya hiyo thermometer na lower limit ya hiyo thermometer, so that inatusaidia sisi kwenye kufanya calculations. So the upper fixed point is the upper limit of a particular measurement of thermometer. So kama ni pressure ni upper limit ya pressure. Kama ni resistance ni upper limit ya resistance, the maximum. And the lower fixed point is the lower limit, which is the minimum measurement ya hiyo thermometer. Kama ni resistance, minimum resistance. Kama ni pressure, minimum pressure. So we shall see the importance of that. Lakini basically kwa thermometers nyingi, the upper fixed point is usually the steam point, the upper limit, that hiyo ndo limit, ndo maximum yetu katika thermometer husika. Steam point, which is usually the boiling point, okay, the 100 degrees centigrade that we know, that is what we call the steam point. In other ways, they define kama temperature at which pure water can coexist in equilibrium with its vapor. We know hiyo ni kwenye steam, maji yakiwa yanachemka mvuke ni 100 degrees centigrade. Now we know ice point ni pale inapoganda, basically ni 0 degrees centigrade when the solid phase is existing in equilibrium with water. That's what we call the ice point, the temperature, the freezing point. Okay, yes. So the temperature, okay, hizi values za x ni value ya particular thermometric property tunayoipima. Kwa mfano kama ni resistance thermometer, hizi x zitakuwa ni resistance. Kama ni constant pressure, hizi x zitakuwa ni volumes. Kama ni constant volume, hizi x zitakuwa pressures. I think you can get me clearly. Kama ni mercury in column, hizi zitakuwa ni length. Likewise, hivyo hivyo. So temperature ya kitu ambacho tunapima ni sawa sawa na thermometric property measurement katika hiyo temperature minus thermometric property value yake at ice point au 0 degrees centigrade, the lower limit, divide by thermometric property ikiwa kwenye maximum temperature, the upper fixed point, which is 100 degrees centigrade, minus the thermometric property measurement ikiwa at 0 degrees centigrade, the ice point. What is the concept of this? The concept of this is, assume tunatumia mercury in column. This is our thermometer. The upper limit sisi tumeweka ni y, call it y, and the lower limit call it x. So we know our total length ya thermometric property, total value ya thermometric property ni maximum, okay, ni maximum y, assuming hii ni 0, it can be anything. So the total here, the total ni sawa na y minus x. So kama hii ni 5, hii ni 0, we know 5 minus 0, tunajua hapa kutoka hapa mpaka hapa ni 5. Nimesema y minus x kutoka kusema y kwa sababu x can be any value. Lower fixed point yetu inaweza ikawa ni 2. Kwa kama hapa ni 2, hapa ni 5. Maana yake length ya hapa katikati ni 5 minus 2. Kwa katikati hapa ni 3, sio tena 5. I think you can get me clear. So suppose tumeweka thermometer yetu katika temperature fulani, ikapanda reading yetu ikasoma hapa, let us say hii ni Q. Okay, let us say hii ni Q. Okay, so the concept is kwamba hii Q ni fraction kiasi gani ya toto. Okay, ni fraction kiasi gani ya toto, kwamba we want this, hii proportion hapa ndio temperature effect ya kuiweka kwenye hicho kitu, kwamba kutokana na kuweka hiyo thermometer kwenye kile kitu imesababisha change ya kutoka Q mpaka X. So ni fraction kiasi gani ya total. So we know ni kama percent. Sawa, tunataka kujua tu ni percent kiasi gani ambayo hii temperature imesababisha katika thermometric property yetu. So ni kama tunavyosema 2 out of 100 times 100 ni sawa na 2%. So nachukua 2 divide by total. That's what we want. So tunachukua hii column hii change ambayo the same tutafanya Q minus X. So Q minus X itakuwa ndo value yetu ambayo imekuwa changed kulingana na kuweka hiyo thermometer kwenye hiyo temperature husika. Divide by total ambao ni y minus x. Y minus x. Then kama tungeamua kumultiply by 100% tungepata percent. Lakini kwa vile tunataka tuidivide katika 100 degrees centigrade kama ni scale yetu 100 degrees centigrade maximum. So tuna multiply na 100 degrees centigrade. Ingekuwa ni percent tungesema the value tunayopata hapa ni percent. Lakini tunataka kuigawa hii thermometer kwa sababu nimesema normally our fixed points tunachukulia ni ice point na steam point. So 0 degrees centigrade na 100 degrees centigrade ndo maximum yetu. Okay, tunataka kujua ni kama percent ngapi kati ya 100 degrees centigrade. Si unanielewa? Yes. So ukiangalia vizuri y ndio hapa fixed point ambayo ni 100 ni hiyo value ya thermometric property ikiwa at 100 ndio hii hapa x100. Na ukiangalia vizuri x ni value ya thermometric property ikiwa at 0 degrees centigrade ambayo ni hii hapa. Na ukiangalia vizuri q ndio value ya thermometric property at a temperature being measured, temperature theta tunayoipima. Na ukiangalia x ni ile ambayo nilisema mwanzo. So basically this is where this formula came from. So now we know why we need fixed points. Now we know what is ice point and what is steam point. We can go to applications of this general formula.
So we have examples and we can therefore utilize our formula. So for instance, you have a particular resistance thermometer. In a resistance at 30 ohms at ice point. Ice point is 0 degrees centigrade. As we shall see better when you triple point, we shall see this. For 1.58 at steam point ni 100 degrees centigrade. And 34.59 ohms when immersed in a boiling liquid ambayo ndo tunataka tu ipime temperature hiyo. So a constant volume gas thermometer yenyewe ina give a reading of that Pascal na hiyo the same three temperatures. It means that ice point and this at steam point and this when immersed in a boiling liquid ambayo tunataka kuipima temperature. So the question is calculate the temperature at which the liquid is boiling. So A on the scale in the gas thermometer, B on the scale of resistance thermometer. So the solution is as I gave the general formula for. So you can see for the first case we are dealing with the first question is scale on the gas thermometer. So gas thermometer is here ambayo inatumia pressures. So pressure at the boiling liquid minus pressure at 0 degrees centigrade or ice point divided by pressure at steam point 100 degrees centigrade minus pressure at ice point which is 0 degrees centigrade times 100 degrees centigrade unapata temperature in degrees Celsius. So as they have defined that, so you can just plug in the numbers if you've understood what I'm saying and you get the temperature in 39.96. Well, ukija kwenye resistance thermometer, the same resistance at the boiling liquid ambayo tunaipima minus resistance at 0 degrees centigrade ice point divided by resistance at 100 degrees centigrade steam point minus resistance at 0 degrees centigrade ice point times 100 degrees centigrade unapata temperature in the platinum resistance thermometer. So as they define that point, you put in the numbers, you get that answer. So you can see the same liquid but they have different readings. And a common question they like asking up and kwa nini they have the difference is because they have different thermometric property and each property varies differently with temperature. So there is a slight variation because not every material that varies with temperature varies in the same way, okay, or in the same proportion. So there is always a slight difference because hapa ni effects za pressure na temperature, hapa ni effects za resistance na temperature. So the other question is resistance R theta of a particular resistance thermometer at Celsius temperature theta as measured by constant volume gas thermometer is given by that much. Okay, ameshakupa equation ya resistance thermometer. If you remember this equation hapa, so may simplify, amekupa kabisa values za products ya hivi vitu ndani. That's what is written hapa. So you can see kwamba R0 R theta ni sawasawa na 50 plus 0.17 plus theta 0.17 theta plus 3 times 10 power negative 4 theta squared. So you can see hii ni ile alpha, hii ni ile beta, and hii ni ile R0, if you remember that formula at the back. So calculate the temperature is measured on the scale of the resistance thermometer, which corresponds to temperature 60 degrees of gas thermometer. So hii temperature aliyokupa ndio hii theta ambayo unaiweka huko ndani. Okay? Ndio hii theta ambayo unaiweka huko ndani, unapata R theta. Unapata resistance at that temperature, hicho kitu unachokisoma. Then you can go back and use the general formula to get your actual temperature on the resistance thermometer. Okay? Kwa mwanzo ambayo imesomwa kwenye gas thermometer, ambayo temperature tunaitumia kuingiza kwenye theta ili kupata resistance katika hiyo temperature. Then tutarudi kwenye general formula yetu, kwa sababu at that time tutakuwa na resistance at that particular temperature ya kitu tunachopima minus resistance at ice point divided by resistance at steam point minus resistance at ice point on 100 degrees. So first we need to have these, but to get the resistance, tofauti na hapa ambapo amesha kuambia kwamba kwenye ikiwa immeasured in boiling liquid resistance ni 34.59, but this time amekupa formula ambayo utaitumia kupata hizi values tatu: ice point, steam point, and at that resistance at that material ambayo inapimwa. So we know that tukitaka R theta tutaingiza value ya 60 kwenye that point, 60 squared hapa ni 60. So tutasolve, tutapata R theta. Okay, as they have done hapa. So you put in 60. Okay, you can see here amekuja kuweka hapa resistance at 60 degrees centigrade. Ukiweka 60 you get the answer is 61.28. So again, but resistance at ice point means ice point is 0 degrees centigrade. So kwenye hii formula unaweka theta ni 0. Then ukiweka theta ni 0 itakuwa 0 na hapa 0 itabaki 50. So resistance is 0 degrees centigrade at ice point ni 50 ohms. Then at steam point 100 degrees centigrade ni 50 times kwenye theta unaweka 100. So hapo utakuja kupata 17 na hapo utakuja kupata ni times 10 100 squared. So 100 squared unakuja kucancel hapa na baki 3. So 3 plus 17 20 plus 50 and 7 tunapata the three values. You put in your formula unakuja kupata the same temperature, the same material ambayo ilikuwa measured 60 degrees centigrade kwenye gas thermometer, huku kwenye resistance thermometer ina read 56.49. As I told you kwamba these values zina differ slightly because of the various or different thermometric property that varies differently in a unique way na resistance.